Welcome to the Analytics Engineering Podcast, featuring conversations with practitioners inventing the future of analytics engineering.
On this episode, Tristan and I sit down with Justin Borgman, who's the co-founder and CEO of Starburst Data, the company behind the open source distributed query engine, Trino. Justin has been in the data world for quite some time. He previously started a company called Adapt, which he eventually sold to Teradata in the first wave of big data and Hadoop technologies. Trino is an interesting tool because it lets you query data without moving it. Justin shares more about the changing of the guard from Hadoop to the modern data stack. And we also get into why data meshes are promising and what seems to work with larger companies.
Since recording this episode, I actually had the opportunity to hang out with Justin in person. And the whole idea, you can query all of your data without having to centralize it anywhere. It's so differently than how I have worked as a data professional that I have this inherent skepticism. But we got into it on the episode, and I actually got into it further with Justin after the fact. But I think I'm getting there. I think I'm becoming a believer.
Yeah, I think it's like pretty unique in how you describe Trino as being like a distributed query engine. There aren't a lot of other technologies that are similar to it. And it comes with its trade-offs for sure, which we go into in the episode. But the promise is really exciting. And so that's what I really enjoyed about this episode. So without further ado, let's get into it.
Justin, thanks so much for joining us.
My pleasure. Thanks for having me.
I generally start out with some personal background questions before Julia digs into the real stuff. So I just want to say, from all my internet stalking, it seems like you've spent your entire life living in the Northeast. First, is that true? And second, hasn't anyone ever told you that it's frowned upon to build a data infrastructure company on the East Coast?
Those are both good questions. And you're almost correct. I was technically born, well, not technically, actually born in Chicago, Illinois.
Okay.
But I moved to the Boston area when I was 1. So almost 40 years now of life in Boston.
There have been prior generations of the data space that have actually had a lot of centrality in Boston, right? Is it Netezza?
Yes, Netezza and Vertica are two great ones. I learned a lot from actually both of those CEOs. CEO of Vertica was a guy named Chris Lynch. CEO of Netezza was Jit Saxena. Learned a ton from both of them. Endeca is another one. Oracle bought them for $1.1 billion.
Yep.
Steve Papa was the founder CEO there. So I have to take issue, I guess, with the early.
I'm with you. We're trying to make East Coast data cool again, too. I don't know if you'll take this as a slight, but I hope not. I had not heard of Adapt before doing the research for this episode, but it seems like there was some stuff that was clear to you. The way that I read this is that Impala and Presto both did SQL for Hadoop in like the 2013 timeframe, but you were doing this before it was cool. Can you tell the story there?
Yeah, no, that's thank you for that. That's exactly right. So yeah, back in 2010 and actually in 2009, my co-founders of that company wrote a paper. They were at Yale. There was a guy named Daniel Abadi, whose prior research actually became Vertica. He was a PhD student under Mike Stonebreaker, and then he became a professor, moved to Yale. And he and one of his first PhD students, Camille, wrote this paper called Hadoop DB in 2009. And Hadoop DB went on to actually win a bunch of awards at a number of different database conferences. The basic idea was thinking about Hadoop as a data warehouse. So you could argue this was the first lakehouse, as people are calling it today, was this paper really. And it did end up inspiring Impala and Presto and a number of the other engines. So that first company was really a commercialization of their research. I sort of convinced them to do that with me, and that was how we got off the ground and built that business over 4 years. And ultimately, that was acquired by Teradata. But a lot of those core principles early on still are very relevant today. Just a few subtle changes. You know, the data lake is now not so much Hadoop anymore; it's more so object storage. But still open data formats, still doing data analytics and data lakes is still a very common, super common thing.
We're going to get to Starburst. Obviously, this is a big part of your story. I'm curious because I don't spend as much personal time in the lake part of the lake house. I'm not as plugged into like what might have changed from the 2010 era of what you were working on to the 2013 era of Presto and Impala. And can you help us understand what has evolved in that window?
In 2010, when we were getting started with Hadapt, the world of open source analytic engines was almost non-existent. The only one that predated us was the early versions of Hive, which were exclusively batch oriented and would take like hours to run. So you couldn't really use it for interactive analyses back then. Our whole idea was, could you build an interactive analytic engine that would be more like a Vertica or Greenplum or Netezza, but allowing you to work on top of Hadoop and really create an open source data warehouse effectively. And in fact, I actually wrote a business plan because that was my first startup and I didn't know what I was doing. So I wrote a business plan, and at the top of it, I remember I said, like, we are going to create the Teradata of Hadoop. That was essentially the value proposition in a nutshell.
At one point, Teradata said, actually.
Yes, that was one of my opening jokes after they acquired us. I was like, no, I really thought we were going to acquire you guys, but I guess, yeah, we had a lot of good fun with that. But to answer your question of kind of what changed over that time period, I think one of the biggest changes was really around performance itself. Because while, Hive and Hadapt were like interesting concepts, and certainly some people were using it, to make it a truly viable alternative to a classic data warehouse, it had to get a lot faster. It had to be able to, and part of that, by the way, was the advent of columnar formats. Because in 2010...
That was pre-columnar format?
That was pre-columnar format. You didn't have RK and ORC or Avro even back then in 2009, 2010. So that was a really big step, was the creation of those columnar formats. Now you had much better query performance as a result of that. But the engines themselves had to evolve. And there was a database analyst at the time that I followed named Kurt Monash back then. I think he's maybe since retired, but he's written a lot of good stuff. It's DBMS2, if anybody really wants to geek out on sort of database history. And one of the things that he said was that it takes like 6 or 7 years to build a functional database. It's just hard. It's just hard to build a query optimizer, a query execution engine. So it takes a while, which is challenging when you're a startup because like you've got to go make money at some point while you're building this database. And I think that's why, you saw the performance sort of steadily increase over time. And each new generation, like Presto, I think learned a lot of the lessons of Hive, certainly, because that was also a Facebook created project.
I didn't know that. Huh.
Yeah. So Hive was created at Facebook, and then Presto basically replaced it at Facebook.
Huh. Okay. As we kind of come closer to the foundation of Presto, the creation of Presto, it starts to edge up against the Starburst story. So can you tell the Presto into Trino into Starburst story? 2014,
Teradata buys Hadapt. Myself and my team become part of Teradata. I became a VP and GM focused on really emerging technologies. Like I like to say that I had like the miscellaneous bucket. The other folks had like the core Teradata data warehousing appliance. I had kind of like the everything else that didn't quite fit into the core business. And the gentleman who was the sponsor for our acquisition, the guy named Scott Now, who's the president of Teradata. I reported to him, and he gave me a very long leash to really explore the future of data warehousing analytics. And it was in that context that I met the guys at Facebook who had created Presto. And Presto was still very early. It was open sourced in 2013. We got to Teradata in 2014. So it was really only used by like a handful of Silicon Valley, like internet giants. Airbnb was early to use it. Netflix was early to use it, but a very limited high class audience, if you will, of internet hyperscalers. And the theory that we had was, could we actually reinvent Teradata around the future of sort of data warehousing analytics being data source agnostic? And to me, what was most exciting about Presto was not just that it was like a better SQL engine for Hadoop, which is, I think, what a lot of people thought of when it first came. It was like, okay, here's another SQL engine, it was a little better, but it was really a SQL engine for anything. And that to me kind of hit a nerve because we saw a lot of customers who were in transition, had a variety of different data silos. They were maybe on-prem, moving to the cloud, moving from Teradata to Redshift, or Snowflake was in its early days at that point. And this represented a way to potentially access everything and create what I like to call optionality, really giving customers the freedom to decide what all those different data sources are going to be at the end of the day. And so that kind of began a collaboration, which I think a lot of people don't even know about the history of Presto, is that Teradata engineers were actually like making Presto great during that period of time. Facebook was as well, of course, but the Teradata contribution, I feel like never fully got the credit it deserved. And along the way, our team at Teradata became some of the leading contributors. If you look at like the top 10 of all time, like half of them are basically Teradata people because of the contributions that we made during that period. And so by 2017, we had started to see some real momentum behind the open source project. More companies were able to use it. You didn't have to be Netflix or Airbnb to deploy it. You could be maybe a more mainstream company. And that represented an opportunity for us to go out and try to build a business around it. And what was a bit unusual, although you have some interesting beginnings as well as a company, is we started as a bootstrap company. We didn't raise that venture for the first couple of years and just basically served the open source community, supported them, started to build enterprise features, created an enterprise edition.
Did you have support contracts? Is that how you paid your
Initially,
salaries?
Yeah. The first 10 months was just strictly support contracts. Yeah.
Huh.
I'm gonna jump in here because I met both of you around the Series A time when I was in venture, and you both kind of had like consulting businesses around this also like core open source project that was really taking off. And in Silicon Valley venture, it was like not popular to back companies on the East Coast or not popular to back consulting companies. And I love just to see like 2 years later, like how far both DBT Labs and Starburst have come. And I'd like for all the venture capitalists that do a lot of like pattern recognition.
This is Julia
just,
patting herself on the back. Is that right?
No, change. I'm not patting myself on the back, but it's just like completely changed the blueprint for like how to build a really phenomenal business. Both of you had this really great open source technology and bootstrapped for the first whatever years before you took on venture money because you knew you had a really big market to go solve. So I just thought that was really similar actually between Starburst and DBT Labs.
Thanks for saying that. Before we lose the thread, I know that we're going to talk more and more about the present day, but I didn't know that, and you called this out, I didn't know that there were commercial contributions to Presto. What was the reasoning? Like, it seems competitive.
You mean at Teradata?
Yeah. Why would Teradata choose to invest in this thing? What was the justification internally?
Yeah, well, I don't know if you're familiar with like Clayton Christensen's, innovator dilemma concept. And I mean, no disrespect to my Teradata colleagues, because I met some amazing human beings, but that company was very much like the poster child of innovator's dilemma. And I viewed like my role, like I had to be there for a couple of years as a result of the acquisition. I viewed my role as like, I'm going to be the guy to try to like, actually solve this. And look, if it doesn't work out, no harm, no foul from my personal perspective, but like it gave me a platform to try to drive change. And I think like to solve the innovator's dilemma, you have to be bold and you have to be willing to cannibalize yourself. Yeah. Teradata ultimately, didn't embrace it the way that I had hoped, partly because there were a number of leadership changes during the time period that I was there.
And, the innovator's dilemma is a dilemma because it's freaking hard. Like, it's very hard to resist the corporate pull of, investing in the thing you already have. Especially
as a publicly traded company, right? You've got quarter after quarter to report on. Like, yeah, absolutely agree.
Okay, that's super interesting. I cede the floor.
Okay. A lot of threads to pull on here. I want to just take a step back, just in case our listeners don't know what Trino is. That's the technology behind Starburst Data. It's a distributed query engine. What does that actually mean? You're just the like compute layer, not the storage layer. Tell people what you're building with Trino.
That's exactly right. One way to think about it is we're like a database without storage. We're the top half of the database. There's a SQL parser, a query, a cost-based optimizer, an execution engine, all the components of a database minus the storage piece. And, another way that I describe it is we allow you to do data warehousing analytics, but without the need for a data warehouse or without the need to consolidate all of your data in one place. And that means that like we just think of everything else as though it's our own storage, whether that's S3 or Azure Data Lake or Google Cloud Storage or even MongoDB or Kafka. And I know we'll get into some of those later. Whatever the source may be, we can query it, but it still gives you tremendous performance and scalability because it is a parallel. It's an MPP system, a massively parallel processing system.
Very cool. So you sit on top of the database storage layer and you don't actually have to move the data. You can just query it in place. It gives people a lot of flexibility because if you don't want to move your data from maybe a system like Teradata that's like hard to move data out of, you can have this like bridge between Teradata world and maybe like a different data store as well.
Yeah, that's definitely one of the applications, and back to that idea of kind of like optionality for our customers. They have that freedom and flexibility to decide where the data is stored today and maybe where it'll be stored tomorrow, and still have a consistent way of accessing, querying, and running their analytics.
It's an interesting like alternative approach. Like if we look at our two giants in the cloud data warehouses space, we have Snowflake and Databricks.
Yep.
In Snowflake, they have a very tightly coupled query and storage layer. They have their own proprietary data format.
Yep.
Whereas Databricks, they have Delta, which is their data lake, but they make these decisions likely because they have to have tight coupling so that they can have the performance improvements. So the data format type is really optimized to work well with the query engine. I'm curious, what are some of the trade-offs that you have with Trino because you don't have the ability to also change the format type? On the storage layer, you have to work across a wide variety of different types of databases.
So that's a great question, and you're absolutely right. So first of all, I would say with respect to Databricks, we're probably a bit more, philosophically aligned with Databricks than we are with Snowflake, in the sense that Delta is just another format for us that we can query and collect statistics on and do the same types of analytical queries on the Delta format. And so the real answer to this question is we rely on the underlying formats that we're querying to organize the data in a performant way. And so, to Tristan's earlier question about the evolution from like flat files, CSV files, that JSON files that people were querying in the very early days of Hadoop, to Parquet and Avro and ORC, which are columnar in the representation. You can get faster read performance out of those, to now like the newest generation, which is Delta and Iceberg and Hootie, from Uber as well. Those are, to me, like maybe the final frontier of this open data format evolution, because those now allow for updates and deletes in addition to performant querying. So I think there's been a convergence over this decade plus period of time where the distance between the performance you could get out of a data warehouse and the performance you could get out of a data lake started off being like way, way, way apart. And I think actually it's one of the things I personally think Cloudera got themselves into a little bit of trouble of, was sort of overselling that in the early days when it wasn't quite there. But it has caught up in a significant way. And I think, you can get very, very similar performance even with these open data formats, as opposed to controlling a proprietary format yourself.
One of the things that I've never totally understood about this, your data can be anywhere, is, and maybe the answer is just like, we give you all the tools and you can make the choices and whatever makes sense for you. But like, you can connect Trino, I think, to Postgres. I think you can even connect it to some SaaS product APIs, right? Like, can you connect it to Salesforce?
Yep.
Okay. We were talking before about the columnar format and its benefits. You're going to achieve a pretty different level of performance if you're like plugged directly into Salesforce versus if you're like querying a Parquet file, right? Like, okay. I just want to make sure that it's not like you can defy the laws of physics here.
No, we haven't done that. That's right. No teleportation. No, that's right. We haven't defied the laws of physics. However, what I would say is that it's important to kind of define performance for your use case or what you're trying to do. Because there may be cases where, let's say you're doing exploratory ad hoc analytics, you've got some questions you want to iterate on, where it may actually be advantageous to, let's say, query Salesforce directly or query various systems directly and save yourself perhaps the days or weeks it might have taken to kind of get that data prepared and ingested into a perfectly manicured data warehouse. So in that sense, a 5-second query versus a 2-second query might actually be, 2 seconds in 2 weeks versus 5 seconds. Sure. And then 5 seconds seems fast. So that's the only thing I would say. And I think, back to you'll probably hear me say this a lot, this idea of optionality, it's sort of like giving you the flexibility to decide, okay, for this exploratory analytic thing, I'm going to go direct to the source because that allows me to at least get an answer today. As opposed to for more refined use cases, maybe it's a dashboard, maybe it's some report that I'm going to run every day. That might be a reason to ingest.
So is it fair to say that almost anything that's SQL compatible you can query, or what are the like bounds of where Trino can work and not work? You have to maintain the actual connectors, but just curious, like, is it everything?
It's a lot of things. So certainly anything that has SQL as a dialect, I would say yes, for sure. But actually even some NoSQL things. So like MongoDB or Cassandra or Elasticsearch or Kafka. And what's happening kind of under the covers without going into painful detail is the connector themselves are basically translating that query to a language that is understood by that underlying data source. And that again gives you some really interesting flexibility where, we have a lot of people that use the Elasticsearch connector actually. They want to incorporate text search in this overall, SQL statement that they're working on.
Yeah, one of the trends that I'm like super excited about, and we've talked about this a few times on the show, is just like the role of the data team is changing, and it's not just for analytical workflows, but actual operational workflows. And then there's a whole different set of like performance characteristics or just a real tool chain that needs to change if you're thinking about having production ready code. You mentioned Mongo, which is normally like something that software engineers are more comfortable building with, or Kafka. How are those use cases different maybe than in like a pure analytical workflow?
Sometimes you have maybe use cases where you want to combine some operational data, and it may be for reasons of freshness, or you just want to combine operational data with log files that you have in S3 or something like that. And this represents the opportunity to do that. Now, a very frequent follow-up question people will ask is like, well, you don't want to bring down that operational system. You don't want to reduce the performance of that operational system. And so we have ways of effectively materializing views so that you're actually querying the view rather than the source system. And you can kind of protect your either OLTP or operational data stores that way. But again, just kind of opens up new possibilities of ways that you can run your queries.
And do you find that it's like different teams that are using this kind of a use case? Is it still, how would you categorize the persona or the human that's actually like doing this kind of work?
Yeah, that's a good question. And it varies a bit. I mean, I would say the ones who certainly take advantage of the full breadth of flexibility are kind of power user, data scientist, data engineer types. But very often these get stitched into kind of materialized views that can be consumed, via Tableau or Power BI or Looker or some kind of BI tool, for a less, technically deep audience, I guess, in that case.
Yeah. One of the things that I think would like be super cool is we're talking about like where does your data sit and what trade-offs you have to make on performance characteristics. Like if you're going to do a join across two different data types sitting in different data stores, it might be challenging to actually like get it in a performance characteristics that you're looking for. What's cool about Trino is like you certainly can move your data to sit in the same warehouse or lakehouse if you want to, and maybe that's like a better performance characteristic for the business user. Or you can decide to like keep things separate. And like you said, it makes it easier you don't actually have to move anything. So you get the benefit there. And so you turn this conversation of like either or into like, yeah, I can have it multiple ways. Have you seen, this gives like more choices though to the customer. So more choices aren't always good because you have lots of questions like, how should I do things? Have you seen any patterns that have worked really well in your customers of like thinking about where to actually keep the data, like keeping it separate versus moving it to a centralized store?
Yeah. So this is a great question. Something we've talked about, because you're absolutely right. When you give people a lot more choices, you're giving them more opportunities to do the wrong thing sometimes. So we want to write a blog post about this of kind of like when to leave it and when to move it. We haven't written it yet, but maybe around the time this podcast comes out.
You're hearing it here first.
Yeah, exactly. And it varies a bit. I mean, I think this is actually something I'm curious to get all of our solution architects involved here at Starburst who are working with customers every day. But I can make a couple high level conclusions, which is that I do think for highly curated data that you have real performance SLAs, those are definitely cases where you probably want to pull it into, and we would argue data lake just because we think, again, that gives our customers more freedom. You could put it into a data warehouse. We would have a preference for a data lake and store it in one of these data formats that we were talking about, whether it's Parquet or ORC or Delta or Iceberg or what have you.
To go one level deeper there, you probably have to all of a sudden take the entire 101 class. We're talking about this like optionality, and this optionality is actually being baked into more platforms. Even Snowflake via their external tables is being more lakey. One of the things that seems to be happening is that each data platform kind of is known for its thing when it originally comes out. And then you get into the marketplace and it turns out that there's probably a fairly consistent thing that you're hearing from your customers as Databricks is, as Snowflake is, et cetera. And so you kind of start converging towards a similar set of functionality. And probably Starburst is forever going to be a little bit better at connecting to different sources than everybody. But do you think that this is a reasonable narrative for the space as a whole? Like there will be a significant amount of overlap as platforms continue to evolve?
I totally get where you're coming from on that. I guess I would say there's a distinction in my mind between convergent messaging and convergent activity.
Sure. That's a very kind way to say what you mean there.
Well, I remember even, again, maybe because I'm old now at this point, but I remember in the early days of Hadoop, every traditional database company, IBM, Oracle, Teradata, all had their like Hadoop story, which was like, we have a Hadoop connector. You can now, access data. Hadoop. And to me, that's not much different from saying we support external tables for Snowflake. It's a way to check a box and say that you have something, but your system was never architected for that type of use case. You lose all the advantages really of Snowflake at that point. Like Snowflake is a really fast database system when you have your data in Snowflake. Yep. When it's out in Snowflake, it's not a very fast database system. So, I think that's distinct from being purpose-built for a new evolved world.
Yeah, and I think we truly believe this. Why we have so many different options is because you have to be really exceptional at one thing, and that's what you're picked, why you're chosen. When the practitioner is actually looking to grab a new warehouse or a new store or whatever it is that they're trying to do, they look for the best tool to do the job. And you become at risk of becoming a master of none once you say you can do everything. I'd love to talk a little bit about like the data mesh. It feels like, Trino's really well set up to play in that world where you do have different teams like picking their tools that they want to use for whatever use case that they have.
Are you secretly funding the entire data mesh movement? Perfect.
I wish. I know. Actually, when it came about, we were like super excited because we had literally nothing to do with it. Zhamak Dehghani came up with the term, and we're like, I think we were made together. Like we love you, Zhamak. It was just too perfect. But yeah, sorry, Julia, you were going somewhere.
Yeah, it's interesting because it's like a combination of both technology that needs to be set up properly for the data mesh, but also organizational empowerment to give teams the right really ability to pick their own tools and work collectively together for the organizational needs. Like, what are some of the things that you've seen like must happen, both from a technological side and from more of a like people operational side to get a data mesh not being just like a mess?
Yeah, great question. And you characterized it, I think, exactly the right way, that it is people, process, and technology. Zhamak uses this fancy word of it being socio-technical, a socio-technical phenomenon. I think that's exactly right. It's not strictly technology, and we remind our customers of that all the time. As much as we would love to say, like, just buy Starburst and you've got a data mesh, it's not quite that simple. So on the technical side, we do think having a query engine and or a query fabric, as some might call it, is a valuable piece of the equation because it opens up the ability to access decentralized data. But there's also this notion of kind of really putting more autonomy and control in the hands of data producers themselves and allowing them to really play a much more meaningful role in the analytical ecosystem than they have historically. Because traditionally, the data producer produces the data and then just like throws it to a central data warehousing team who probably doesn't understand the data. I mean, in my like 10 or 12 years of doing this, I can't tell you how many times our customers in a central data warehousing team don't actually know what queries are being run or what the use cases are, because they're just focused on the technical aspect and don't really understand necessarily the data itself. And so data mesh helps to solve that problem as well by allowing the domain owners, the people who really understand the data, to play a role. And so we think part of making that happen is starting to think about data as a product. And we've been evolving our own product in this direction to allow data producers to basically curate their own data sets. And sometimes these are materialized views across multiple database systems as well that can then be shared and published to the rest of the organization and consumed. And so that's one step of, again, technologically, how we're trying to help further that. But part of it is just, again, kind of like a new way of thinking, and you have to get more and more people on board. And I think, sometimes central IT could feel threatened by a data mesh because they could say like, well, am I giving up too much control to the edge? I think central IT still has a really important role to play by managing the infrastructure of this data mesh. But you're putting more power in the hands of the data producers to really curate the right data sets, which is ultimately going to drive more consumption, I think, across the board and further this notion of self-service and data democratization that everybody wants.
And I think at the largest companies, there's also some fear that you're giving sensitive data to lots of different teams. So there needs to be like proper governance alongside a data mesh so that certain teams can see some types of data. If there's PII data, it's properly masked. I think that's like a hard thing to get right.
Yep.
What are the main detractors in your mind why companies haven't gotten to data mesh yet?
Part of it is its newness, but I think you're right. I think getting the governance piece right is really, really important. If you're going to have a way of accessing all of your data, you need to have access control for all of your data. And I think that's a really necessary component. I would say that's probably one of the biggest challenges. The other is also just, I think with any new idea, trying to evangelize it internally and get people bought in.
Totally. Yeah. It's the people, process, and technology were the three. Yeah, totally. We talk a lot about modern data stack on this podcast. I think we have our ideals of the way the world should work. And often that's different than how things are actually done in practice, especially at really large organizations that have complex needs, have made lots of investments over many decades in data. I think you sit at this really interesting vantage point because you sit as this abstraction layer across a lot of different investments that you may have made, new investments, old investments, and you create that bridge for the Oracle, Teradata users of the world to also dip their toe in what we call more modern data stack. Where do you think we are actually in the cloud adoption for the data ecosystem? And what do modern data stack zealots just get wrong about the realities of really large companies?
I'll answer the first one first. It'll be a guess, maybe an educated guess, but a guess. I'm going to say we're somewhere in the 50-50 range in terms of the move to the cloud. I think we made a tremendous amount of progress over the last 10 years. As an aside, when I was doing that first company, people were talking about cloud. It was actually a very popular buzzword, but probably 1% of the data was in the cloud in 2010 or 11 or whatever. So I think we moved a major way, but I do think, something like half of the data is still sitting on-prem. And I think the thing that people don't realize or sometimes maybe underestimate is the tendency towards heterogeneity. I guess it's almost like, the natural evolution towards chaos in the universe in the sense that different departments are going to do their own thing. You're going to have new application developers creating their own database somewhere. You're going to buy companies and inherit their data stack. And so this notion of everything living in one clean central place, I think is something that has never been possible in history, even if you look at what Teradata tried to do over 40 years. And I don't think it'll be possible in the next 40 years either. And part of that data will maybe continue to live on-prem, particularly for large enterprises. There's also actually the counter trend, and I'm not saying that the world goes this way, but there are also some very large companies that realize that they're spending way too much money and then go backwards, right? There are even a few examples of that. So I think we're just going to live in a very heterogeneous world, maybe forever. And I think, even in the cloud context, even companies that are fully in the cloud, we see them, say we're just going to be an AWS shop, and then they go buy a company and now they have data in Azure and Google too. So you're going to have multi-cloud as well.
Here's where I was going to go, and then maybe your last point has already convinced me otherwise. But the argument of we've never seen homogeneity in data in 40 years of data. I think that we've also never seen hyperscale cloud providers in the way that we see them today. And so it's very hard to reason from priors. I find myself, and maybe this is overblown, but I find myself thinking a lot about the transition to mobile. We had this incredible variety of handset form factors, and they were largely terrible. And very quickly, the entirety of humanity, or a very significant portion thereof, adopted these new form factors, and they were just really two vendors that were supplying them. So I think it's totally possible to take the other side of your argument, but then you bring up multi-cloud, and maybe that's the bridge that you will never actually see a sufficiently complex organization that has all of their data in a single cloud provider. I'd be willing to say that.
I think you both can be right in that we will always have heterogeneity, but we will have more consolidation in a few key players where you'll move a vast majority of your data to one of the big data warehouse clouds, and you'll have just the leaders will really pull ahead. I think you will always have some heterogeneity just because getting to 100% is just not going to happen.
Yeah, definitely.
Yeah. And it's interesting too, like the way that these companies can now service customers in the cloud, like their friction for just growing with the companies has become so much easier. Like you don't have to actually buy an appliance to actually grow. You can just burst in cloud and scale. And so it makes it easier to buy, it makes it easier to deliver. And so I think that you will see more consolidation in big players, but we will always live in this world where it's like, it won't just be one, it will always be a few. And when you have a few, then you have complexities around managing data across different stores.
Well, let me ask a question. I'm curious your thoughts on this. So in the homogeneity view of, let's say, a large portion of data living in one place, do you think that is a cloud data warehouse, or do you think it is a cloud data lake?
If there is to be that level of homogeneity, it will have to be open and standards based.
Mm-hmm.
I find it hard to imagine that a closed platform will ever be able to achieve such massive market share that customers will not tolerate that. So I think that what we're seeing in the market today is actually driven by the fact that we're only a reasonably small degree penetrated by the major cloud data platforms. There's still just so much more to go.
Mm-hmm.
Yep, I agree with that point. By the way, I think we would definitely agree there, and it's something that we talk about as well. That we do think the largest center of gravity will be a data lake, and we think it's because of the open data formats, which give you portability too. Mm-hmm. So even if you think about the multi-cloud world, at least you're portable. Because if you go the cloud data warehouse route, then you've really got like 4 choices, each of which lock you in pretty severely. You know, it could be Snowflake, or it could be one of the clouds, individual cloud data warehouse, right? Like BigQuery or Synapse or Redshift. And in any of those cases, you're sort of stuck once you're there. It's a lot harder to move. And I think that data lakes and open data formats give you much more optionality again.
I hope that we're moving towards a place where data engineering, rather than one of the main jobs of data engineering being landing the data in the lake at all, it will be starting with data in S3 or whatever blob storage and making subsets of it available in different file formats so that it can be read and written more performantly for different use cases in different platforms. So you have your lake that has, many, many petabytes. You have some subset of that you need different access patterns to, and that gets loaded into your warehouse and, et cetera. And so, but insofar as that the formats are coupled to the performance characteristics, the data engineers will still have to make sure that I don't think you can just say our format for everything is X and that's just the end of the story.
Mm-hmm.
You get streaming in there, and Materialize has to use its own format to be able to do what it does. And I don't think you're ever going to see complete consolidation for every use case on a single format.
Yeah.
This has been fun.
Yeah. We're going to ask one final wrap-up question, which we ask to all our guests. But looking 10 years out, Justin, what do you hope will be true for the data industry?
What do I think will be true for the data industry, or hope will be true?
Hope. Be an optimist.
All right. Yeah. I hope that companies have, and it actually dovetails with our most recent conversation, that companies have the freedom ultimately to decide how and where they're going to store their data without being constrained. Like, to me, I guess when I think about at least my time in the history of databases, there was, a revolution in the early days of Hadoop really against proprietary systems because of the lock-in that people felt. And I think, those foundations are just as important today as they were back then. And so I hope we live in a world where customers have the choice, where customers have the freedom to decide. I think that's best for them. I think that's, hopefully where things go over time.
I like that answer.
Justin, thanks so much for joining us. Where can people find more from you online?
They can certainly reach out to me. I would say Justin at starburst.io. Feel free to send me an email. I love hearing from folks and happy to continue to talk about this stuff. This is what I basically geek out on all day, as you can tell. So, feel free to find me and would love to chat more.
Thanks so much.
The Analytics Engineering Podcast is sponsored by DBT Labs and is hosted by Tristan Handy and myself, Julia Schottenstein. Have comments, questions, or guest suggestions? Email us at podcast@dbtlabs.com. Our producers are Jeff Fox and David Krevitt. If you enjoy the show, please drop a review or share it with a friend. Thanks for listening.